right, let's look at some of these questions involving trig and the area underneath a curve. I'm checking that it should be, yeah, the microphone's on, so we're good to go. So, I'm going to show that these curves intersect at this point. So the best way to do this one is you will simply, what we will do is we're going to just do a straight substitution. We're going to put in sine pi on 3, which is the same as sine of 60. Remember, when you're not sure, you have pi on 3, replace the pi with the 1, and multiply it by 180. And then you're going to do the same. Remember the same, replace the pi with a 1. 2 times 1 is 1. 2 over 3 times 180 is 120. Sub them in. And these are going to end up being the same. They're both going to be the square root of 3 on 2, which is like 0.867 or something. A simple substitution will check this out. So we know that this point right there, where these curves intersect, is pi on 3. So let's sketch these curves in the interval. I've done that right here to make things easier. The black one is y is equal to sine x. And we know that the curve of sine x goes up and down, where sine of pi is 0. Sine of pi on 2 or 90 is 1. You can see my beautiful peak right there. And we know sine of 2x doubles the period, which means a sine curve is going to happen over pi instead of 2 pi. And we can find that out. Remember what we did before, where we made that be equal to 2 pi, which is what it normally is. X is equal to pi, which means that our sine graph does a full sine, so it goes up, down, and back to the start every pi units. That's something we covered in trig before. So let's actually go through and look at the final part now. We're going to find the area between the two curves, and what we're going to need to do with that is we're going to need to subtract them. The curve at the top, which we can see is our red curve, minus the curve at the bottom, which is my black curve. And we're going to do that between pi on 3 and 0. Sine of 2x minus sine of x. And we're going to integrate them. And we do these using our trig rules. We just do them separately, remembering that sine goes to negative cos, and it's 1 over the coefficient of x. So sine of 2x is going to be negative 1 over 2 cos 2x. I've got a negative here, so that's going to be plus cos x. And that's between pi on 3 and 0. Make some substitutions in now, like what we do. Negative 1 over 2 cos 2 pi on 3 plus cos pi on 3 minus negative 1 over 2 cos of 0 plus cos of 0. Lovely. You can make these back into degrees if you want to keep your calculator into degrees and calculate them. And when we do that, we're going to end up with the following. We're going to end up with, I've got the answer sitting right here to make things a little bit easier. This ends up being 1 over 4 plus 1 over 2 minus negative 1 over 2 plus 1. If you want to find out what those are, simply type this into your calculator. I already did it to make things a little bit easier for me. And that gives me my area, which is 1 over 4 units squared, which is sometimes stylized as u squared for some strange reason that isn't totally known. So then we've got our second question, and I'm going to leave this up there for you guys to take a look at as well. So you may want to take like a little screenshot just so you've got it in front of you and make things a little bit easier as well. There it is, take your screenshot. We're going to sketch that cos curve, and then we're going to find the area between the curve and the x-axis. All right, so now you've got it in front of you. Second part, it's y equals cos 1 over 2x between 0 and 4 pi. Usually it's between 0 and 2 pi, which is 360. So this will be between 0 and 4 pi, which is 720. We're going to keep dealing with pi because that's what we're used to dealing with so far. Remembering what we look at, first let's look at the amplitude. No, and by amplitude I mean period, which is half x equal to 2 pi. Find out what x is equal to 4 pi. That means our cos graph is going to do our full revolution from top to top every 4 pi. That's going to make things a lot easier for us. We roll up our cos graph. That is one of the worst axes I've ever drawn, but we let it go. The amplitude stays the same, 1, -1. 4 pi is going to be there, so we know it's going to start there and peak back there. We have 2 pi in the middle, which is where it's going to end up being at a dip. It's going to come back up, and you can probably imagine this is going to be pi. That's going to be 3 pi. Hold on. It's organic. We let it go. We ride on. Valhalla awaits. I'll be riding to Valhalla tonight, let me tell you that much. So now we go back to the question. We want to find the area. And again, if you're not sure what these are going to be, simply plug it in. It's probably going to be pi, or it's probably going to be pi or 2. So that's 180 or 90. So we want to find the area between the curve and the x-axis. So we have this area there, that area there, and that area there. And we want to do these 3 separately. That's going to be important because remember, when it's below the x-axis, it ends up being negative. Unless you're subtracting areas from curves, then it ends up getting a little bit funky in that regard at times. So let's look at these 3 separate integrations. We got our first one, which is between pi and 0. And remember, we're integrating cos of 1 over 2x. Plus our second one between 3 pi and pi, which is the same curve. Plus our final one between 4 pi and 3 pi. I don't know why my integral sign's getting larger each time. So let's look at doing all these 3 ones separately. Here we go. The first one, what does cos integrate to? Cos integrates to sine, and it's 1 over the coefficient. So it's going to be 1 over a half, 0.5, sine 1 over 2x, and we're going to be putting in pi and 0. Plus the same, because we're integrating the same thing. It's alright just to have this all laid out like this. It's going to be a bit messy, but we ride on, we don't get discouraged. And we can know that 1 over 0.5 is the same as 1 divided by a half, which is the same as 2. So 1 divided by 0.5, 1 divided by a half, our fraction rules, 2. So let's just get through, let's do the first substitution in. I'm just going to go straight to, so we have 2 sine, a half times pi is pi on 2, minus 2 sine, a half times 0 is 0. That's going to give you, we know that sine of pi on 2 is the same as sine of 90, which is 1. If you're not sure, put it into calculator. It's okay to do these things. Sine of 90 is 1 times 2 is 2. Sine of 0 is 0. So 2 minus 0, it's just going to be 2. The next one, we've got 2 sine of a half times 3 pi. 3 pi on 2 minus 2 sine a half x pi. Pi on 2. Let's put these in again if we're not sure what it is. 3 pi on 2 ends up being the same as, we can work it out again. It's going to end up being, put it in, type it in, it ends up being -1. -1 times 2, -2. If you're not sure, type it in. Minus, we just did this one before, we know it's 2. Plus -4, we're going to come back to that one in a sec. Plus, and then the final one, which we're going to look over here. We know that 2 sine of 3 pi on 2 minus 2 sine of 2 pi, because 4 pi over 2 is the same as 2 pi. Plus, we know what this one is already. We did that one before. We know it's going to be negative. No, what have I done? Wrong way around. Mistake. This is sine of 2 pi. This one here is 3 pi on 2. Make sure that you're substituting in the top one into the left, which I've done on every single one except that one. 2 sine of 2 pi ends up being 0. Sine of 2 pi, sine of 360 is 0. Not sure? Type it in your calculator. Minus, we know 2 sine. We got from this one here, we know it's -2. So we have 2, oh my god. There we go. -2. I'm not changing any of this. Whereas it's raw in the flesh. So we know it's going to be 2 plus -4 plus 2. This, under the curve it's negative, which means we need to take the absolute value so it ends up being positive. And squared because it's area. A lot what's happening here, and it's going to be a lot of past knowledge about drawing those graphs, and once you've drawn the graphs, taking your time, typing stuff in the calculator, convert it to degrees if you need to, but if you look at something I've done and say you don't get it, type it into your calculator in the correct mode, radians or degrees, before you get confused. So take a second. And that is looking at some application of integration in relation to trig.